In section 11.2, we're going to go through and talk about arithmetic sequences and series. An arithmetic sequence is a set of numbers in which you're adding a common number to the previous number each time. The general equation for arithmetic sequence is a sub n equals a sub 1 plus n minus 1 times d, where a sub n would be the nth term of the sequence, a sub 1 is your first term of the sequence, n is the number of terms in the sequence, and d is that common number that you're adding or subtracting each time. So let's take a look at an arithmetic sequence. Here we want to write an equation for the nth term of this arithmetic sequence. So the equation, a sub n equals a sub 1 plus n minus 1 times d is what we'll use. I want to find the nth term. The first term of the sequence is going to be negative 8. How many terms are there in the sequence? Not sure. That's what we want to find out. And d is that common difference. What's the difference between each one of those? Well, it looks like I'm adding 2 each time, so the d value would be 2. So this is the equation that we wanted to come up with for example 1. Now let's just go through and show you how this works. Let's say that I wanted to find the third term of the sequence. Well, I know the third term is going to be negative 4. Okay, so what do I want to find? A sub 3, the third term of the sequence. Negative 8 plus n, how many terms are there in the sequence? 3 minus 1 times the 2, which is your common difference. So this says a sub 3, which is the third term of the sequence, should be 2 times 2 would be 4. Negative 8 plus 4 would be negative 4. Is the third term negative 4? Yes, it is. So that's how you can then use the formula that you come up with to find different values. Now, a lot of you are saying, well, I could have just looked, or I could have continued my sequence a little bit further. But what happens if I want to find the 30th term or the 50th term? Then the formula comes in very handy. Okay, let's give this one a try. Find the 20th term of this sequence. So I'll go ahead and write the formula up here again. A sub n equals a sub 1 plus n minus 1 times d. I want to find the 20th term of the sequence. The first term is 3. The 20th term is what I want to find, so that's the n value, minus 1 times d. What's the distance in between? That'd be 7. So a sub 20 is actually going to be 3 plus 19 times 7. If I take 19 times 7, that should be 133, and I'll go ahead and add the 3 on. So the 20th term of this sequence should be 136. Okay. Similar to what we did when we were justifying our steps in example 1. Plug in the information and evaluate the term. Okay. Let's take a look at example 3. Write an equation for the nth term if a sub 6 equals 11 and d equals negative 11. So we need to go through and write an equation for the nth term. Well, from my general equation here, a sub n equals a sub 1 plus n minus 1 times d, it looks like I'm missing a sub 1. So let's go through and plug in our information to see if we can come up with what a sub 1 would equal. Well, a sub 6, okay, that equals a sub 1 plus n is 6 minus 1, and they told you what d is. D is negative 11. Okay, and we know a sub 6 is 11. So now I should be able to solve for a sub 1. 11 equals a sub 1 plus 5 times negative 11. Okay, so that would be negative 55. If I add then 55 to both sides, a sub 1 then will be 66. Now that I have a sub 1 as 66, I can go through and write my equation for the nth term. A sub n equals a sub 1, which is 66, plus n minus 1 times the d value. The d value in this case was negative 11. So now I can go through, once I found a sub n, I can go through and find any term of this sequence. This is a little bit different one. Negative 14 is the blank term of the sequence. So again, we're just using this formula. Let's start with a sub n equals a sub 1 plus n minus 1 times d. Negative 14 is the last term. The first term of the sequence is 2 1/5. We want to find out negative 14 is what term, so that'll be the n that I'm trying to find. And it looks like the d value, I'm subtracting 1/5 each time. So let's go through and solve this algebraically. First thing I'm going to do is rewrite negative 14 as negative 70 over 5. That'll help me because this will be an improper fraction. This will be 11/5. So now I got a common denominator of 5. I'll start by subtracting 11/5 from both sides. So that'll be negative 81 over 5 equals n minus 1 times negative 1/5. Let's multiply both sides by negative 5. So that'll be 81 equals n minus 1. Add 1 to both sides, n should equal 82. So negative 14 should be the 82nd term of this sequence. And then the last thing that we want to do with our arithmetic sequences is we want to be able to find the 6 arithmetic means between 12 and 47. So what that means is I have 12, and then there's going to be 6 numbers, and then there'll be 47. So what I want to do is I want to find each one of those 6 numbers as I'm going through. So let's go through and use our formula again. That's what we have the formula for. So this would be a sub n equals a sub 1 plus n minus 1 times d, which is the distance in between. What we're after here is the distance that's going to be in between, because as soon as I find that, then I can start with 12 and add or subtract that distance each time. So a sub n is the last term, 47. A sub 1 is the first term, 12. Number of terms in the sequence, there's going to be 8 of them. Now I'm after d. So let's subtract 12 from both sides. Subtracting 12 from both sides, that'll give me 35 equals 7 times d. The distance in between is going to be 5. So now that I got the distance in between, I should be able to go through and find each one. 12 plus 5 would be 17. Plus another 5 would be 23. Oh, sorry, 22. Then 27, then 32, then 37, and then 42, and then the next one would be 47. So we call those the 6 arithmetic means between 12 and 47. Next thing that we want to do then is we want to go through and talk about a series. What is the difference between a sequence and a series? Well, your sequence is the set of numbers where I'm adding or subtracting the same number each time to the previous number. Like in this sequence, I'd be adding 3 each time to the previous number. The series is when you take the sequence and you add the numbers together. So that's the difference between a sequence and a series. So in this one, the sum of a finite arithmetic series, S sub n, that means the sum of n numbers, equals n divided by 2, the number of terms in the series divided by 2, and then you have a sub 1 plus a sub n, first term plus last term. Let's just take a very basic one and show you how to do this. Let's say we had the series as 1 plus 2 plus 3 plus 4. This is the first 4 terms, or the first 4 integer values, and I'm going to find the series. So if I add those up, I'd end up with 1 plus 2 is 3, plus 3 is 9, or 6 plus 4 is 10. So we end up with 10 when we add those together. Let's just show you that this formula does work. S sub n, the sum of the series, that's what I want to know, equals number of terms. Here there were 4 terms. So 4 divided by 2. First term was 1. Last term was 4. S sub n, what's the sum? That'd be 2 times 5, which is 10. Notice that's what we came up with here when we added them up. So once our series gets bigger and we use larger numbers, we're going to be able to go through and find the sum using the formula. Let's try one. In this one, we want to find the sum of the first 50 positive integers. Okay, so positive integers, 1, 2, 3, 4, so on and so forth. So let's use our formula. I'll write it up here. S sub n equals n divided by 2, a sub 1 plus a sub n. So we want to find the sum. How many terms are there in my series? Well, first 50 integers, so 50 of them divided by 2. First one would be 1. The last one would be the number 50. So this is 25 times 51. If I multiply that out, I should get 1,275. So if I added 1 plus 2 plus 3 plus 4 plus 5, so on and so forth, all the way up to 50, the sum of those would be 1,275. Let's do a little different problem with the same formula. Find the first 3 terms of the series. If a sub 1 is 14, a sub n is negative 85, and s sub n is negative 1,207. So I know I'm going to start with the s sub n equation. S sub n equals n divided by 2, a sub 1 plus a sub n. Okay, and that should get us going with the problem. S sub n is negative 1207. And number of terms in the series, that's what I'm going to be after to start out. I need the number of terms. First term was 14, nth term was negative 85. So what I'll do is I'll start by going through and adding these together. So negative 1,207 equals n divided by 2 times negative 71. Then I'll multiply both sides by 2 to get rid of the fraction. So if I do that, I should get negative 2,414 equals n times negative 71. Divide by negative 71, and n would equal 34. Now what am I trying to find? I'm trying to find the first 3 terms. So what I need is the d value. So I have the n here. So now I'll go to my second step and I'll use the original formula that I had for a sequence, which was a sub n equaled a sub 1 plus n minus 1 times d. I'm after d so I can find the first three terms of the series. So a sub n we were given as negative 85. First term of the series, 14, plus n minus 1. Well, now we know n is 34, so 34 minus 1 times d. Let's go ahead and subtract 14 from both sides of the equation. So that would be negative 99 equals 33d. So d is going to equal negative 3. So then to answer the question, what are the first three terms of the series? The first term's 14. The next one I have to subtract, so that's going to be, subtract 3 would be 11, and then the third term would be 8. And notice that we're going down, and as we go through the 34 terms, since we're going down, we're getting in the negative direction. That's why the sum turned out to be a negative 1,207. So the first three terms of this series would be 14, 11, and then 8. Okay. And then the last one that we're going to do, we're going to introduce something called summation notation. And they use the Greek letter sigma in order to go through and do the summation notation. So let me kind of go through and show you how to apply this. This says we want the sum of the terms, S sub n, okay, where the first n value is going to be 3, the last n value will be 8. So we want the third term plus the fourth term plus the fifth term, so on and so forth. Okay? And then we have the equation, 3n plus 7 is what we're going to go through and do. So how many terms is this sequence going to have in it? Well, 8 minus 3 is 5, but then I have to add 1 since I'm counting both the third and the eighth. So we want the sum of the third term through the eighth term. That's 3, 4, 5, 6, 7, 8. That's 6 terms in my series. So n is 6. We're going to divide that by 2. And then we had a sub 1. What's my first term going to be? Or this would be the value n equals 3. So if I plug in 3, I get 9. 9 plus 7 is 16. And then I have to find the last term, which was when n was 8. So when n is 8, that would be 24, 31. So this series contains 6 terms. The first term is going to be when n is 3. The last term, or the sixth term, will be when n is 8. So as I go through here, the sum of the first 6 terms of my series will be 3 times 16 plus 31. That's going to be, let's see here, 47. So the sum of the 6 terms of my series then, 3 times 47, should give you 141. So as I go through, basically what this means is if I added up the 6 terms when the n value was 3 to the n value was 8. We found the first one being 16, right? The second one would be if it was 4, so that would have been 12, 19. And let's see, 3, 4. The fifth one would have been 15, 22. So you can kind of see what's happening with my series already, right? Since it's an arithmetic series, I'm adding 3 each time. 22, 25, 28. And then the last one was 31, correct? So let me take this, bring it over here. and then 31. So those were the 6 terms in my arithmetic series. So if I add those up, what do you end up with? You're going to end up with 141. So that kind of shows you how the formula relates to the actual series. Okay? And that will conclude the notes for section 11.2, arithmetic sequences and series.